Today we're going to look at the distance between a point and a line in the xy coordinate plane. This is the formula. D is for distance, and I'll talk you through how to prove it right now. So first we draw the xy coordinate plane. Now I'm only going to draw the first quadrant because let's just make today's activity take place in the first quadrant for simplicity's sake. Now we need a line. Where's our line? Let's say this is our line. Now I'll make it like this. Okay, our point. Our point should be somewhere here. So we have a point and a line. Now what's the distance? Is it this distance? No. Is it this distance? No. It's this perpendicular distance. Like this. Right? This is perpendicular. Now let's just call a point P. And P has coordinates of x1 and y1. I'm naming them x1 and y1 because those are corresponding to these x1 and y1s inside the formula. So this is actually just the coordinates of P. So we have a point P. So what about the equation for our line? We also want that, right? Where did ABC come from? They're part of the equation. They're the coefficients and the constant of the equation, if you can imagine it. So we know that we have a line, and it has equation ax plus by plus c equals 0. So the standard form. Okay, so let's just start to work. Let's just get to work. So the first thing we're going to do to prove this formula is we start from point P and we drop a line like this. We drop a line that is vertical and is parallel to the y-axis. So it's parallel to the y-axis, and essentially we have a right triangle, right? So let me just name the right triangle. P, Q, R. So let's just have some coordinates for Q and R. Now which one looks easier to figure out? It seems like R seems easier to figure out because at least we have the x coordinate for it. Right? The x coordinate for R is just going to be x1. The y coordinate, though, it might be a bit harder, but not hard. We know that R is on this line, and we have the equation of this line here. So we just plug x1 into the equation, we solve for y. If we just plug x1, we know that we have ax1 plus by plus c equals 0. So if we actually make y the subject, y is actually equal to negative ax minus c over b. Now we plug x equals to x1, then we get the y coordinate for this is negative ax1 minus c over b. So that's our coordinates for R. Now let's just ignore Q because we only need R. So after we have R, what do we do now? Well, so we have written this equation like this. So maybe we should write it even better. Like we should write slope. So the slope is negative a over b x, and the slope and also the intersection. The slope intercept form. So negative a over b x and negative c over b. Right? And then so we have our slope, which is negative a over b. Now since our slope or our gradient is equal to negative a over b, this means that when I start from a random point here, this is a really random point, if I move b units to the right, because that's rise, it's rise over run, right? So that's rise, a is rise, b is run. If I move b units on the horizontal direction like this, then what do I get? Well, my resulting point here, is this. So I've moved b units in the horizontal direction and negative a units in the vertical direction. So this length here is going to be the absolute value of negative a. This length here is the absolute value of b. So this is obviously perpendicular because, well, one is moving along the x-axis, one is moving along the y-axis. So we have another right triangle. And I'm just going to call this, let's see, TUV. So I'm going to call this TUV. Now what else can we do then? Like, how's this helpful? Well, we realized that we can use transversal lines because, so we have to try and use the geometry aspect of this thing. Although it's in the coordinate plane and it sounds more like algebraic things, if you use algebra, you're gonna spend way longer improving this formula than when you use geometry. Using geometry, we know that VU is parallel to, well, RP, right? That's kind of obvious. Okay, so since that happens, so because they're parallel, we know that angle, angle PRQ is equal to angle UVT. So, why is that? Because we have transversal lines. So this is the transversal line. It goes through PR and UV. So corresponding angles are equal. So these two angles are gonna be equal. So we have two equal angles in two triangles. We have the right angle and we have another random angle. So this means that all the angles in this triangle are equal. This tells us that the two triangles PQR and so triangle PQR and triangle TUV are similar to each other, and they're similar because of the angle-angle theorem. So since they're similar, we can have some ratios, right? So since they're similar, then we have some ratios of the corresponding sides. We have PQ over PR, or actually, we have we have PQ over PR, and that's equal to, well, TU over TV. Okay, so we can use this because this is like the closest thing we have in this whole process to a fraction. Well, except for this, but that doesn't really help much right now. So that's like a fraction equation. So we can use this. So we know that PQ is what we're looking for. PQ is just D, because D is the distance from the point to the line. So PQ is just D, right? And PR is, well, PR, what's PR? PR is Y1. So the length of PR is the magnitude, the absolute value of Y1 minus AX1 minus C over B. Like that. And that's equal to TU over TV. So let me just make this clearer. This is TU over TV. Now what's TU? TU is, so TU is, the length of TU is the absolute value of B. TV, this line is, if we use the Pythagorean theorem, if this is the absolute value of B and this is the absolute value of negative A, the resulting length would be root A squared plus B squared, right? Now we're starting to see something similar. These two are equal, so we're probably going the right direction if we see some similar components between the formula and whatever we're working with. Okay, so we want D on one side, so let's just multiply both sides by this this absolute value thing here. We get the absolute value of B times Y1 minus AX1 minus C over B. And then that's absolute value over root A squared plus B squared. So therefore, this is equal to, so we multiply the numerator out. The numerator would be equal to BY1 plus AX1 plus C over root A squared plus B squared. And then that's also equal to, so we can reorder this, right? We can reorder this so that we get AX1 at the front, and we add C, we add B, Y1, and we add C, and we take that over root a squared plus b squared. So that's just our formula. We've got the same thing. We got d is equal to the absolute value of ax1 plus by1 plus c over root a squared plus b squared. So thanks for watching. Bye. Remember to figure out this formula and prove it on your own.